All right, that's great. Great to see so many numbers. Tēnā koutou katoa, everybody. Thank you very much for joining us. My name's Shane Clark. I'm the General Manager here at Nuralite Waterproofing. For those of you who don't know, Nuralite has been synonymous with flat roofing, waterproofing products for the last 55 years. We distribute a range of roofing solutions, single-ply membranes, along with double-layer bitumen systems. We also supply a range of below-ground tanking options as well. So that's what we do, and that's who I am. I'd like to thank you all very much for joining us here today. A few people joining the room, it's great to see. Lucky enough to have with me today on the panel Internal Technical Advisor Peter Mills. Hey Pete.
Hey everyone. Hey Shane.
And I've also got Jade hiding behind the camera, producing all our slides and whatnot. So morning Jade, how are you going?
Hey guys.
Excellent. Yeah, great. Yeah, thanks again for your time. The session, this online learning session, is set for 30 minutes. We're going to talk for about 20 odd minutes, and then we've got 10 minutes at the end towards the Q&A. So we try and make this as interactive as possible. Please feel free to use the Q&A function at the bottom, and we can run a couple of polls in that while we go through this. So try and make it interactive. We're not in your offices, obviously, so we sort of become a bit two-dimensional. So jump in, make it interactive as you like. Otherwise, you're going to be staring at some talking heads for 20 minutes. All right. So the other part of the setup we have in our online learning sessions is normally if we're in your office, we'd bring you sausage rolls and things like that. So we're not. So what we're going to do is we're going to take that budget, and for every attendee here today, we're going to donate $10 to our chosen charity. Who's our charity this time, Jade?
For this session, we're actually sponsoring Westpac Helicopter, who do a lot of good things throughout New Zealand. So thanks for coming and supporting them, guys. Yeah,
great. No, that's awesome. So great sponsor to have, and you've made the world a better place simply by attending here today. So that's fantastic. So today's topic is around single-ply membranes. We'll talk about specifically what we're going to focus in on very shortly. But first thing we're going to do is kick off with a bit of a poll. There's a lot of designers and whatnot in the room, obviously. We're even humbled to have some of our fellow suppliers in the industry join us too. So good morning to you. So we're going to flick this poll up. We let it run for about 30 seconds. Are you aware of any issues from your perspective with single-ply membranes? So feel free to populate that. And then what we'll do at the end of this webinar is we'll then send out the package, which includes all the results to these polls, also the Q&A sessions, and a copy of all the reports that we're going to refer to today. So awesome. All right. Thanks very much for your participation in that. All right. So like I said earlier, our topic today is around single-ply membranes. We're going to be focusing in on one thing in particular. So, I mean, one thing that we're really, really good at doing in the construction industry in New Zealand is highlighting all the wonderful things we do, producing glossy brochures, fancy pictures, great websites, and shouting from the rooftops all the wonderful things that we've done and achieved. One thing I've noticed in my time in the construction industry we don't do is we don't share our learnings that well. Things that don't go so well, we don't promote those things, which is completely contrary to other industries such as the aeroplane industry, for example. So I mean, I'm sure you're aware that when something goes wrong with a Boeing aircraft, it becomes quite a public spectacle. Boeing then sit down with all the other people involved, and they nut out the issue, they highlight the issue, and they make sure it doesn't happen again. We just don't want to keep repeating these same mistakes. And that's something that we've learned in our 55 years of industry knowledge, specific to what we're doing. So today's specific topic around single plies is specifically around why we want you to consider the unintended consequences of using a dark and thin single ply membrane. So those are the things we're going to focus on. We're talking about thin membranes and dark membranes and things that we need to watch and consider around that. Where are we up to now? We're going to, okay. First of all, what is a single ply membrane? A single ply membrane looks like this when it comes out of a factory. So it's a factory made product made in a very controlled environment to some very specific dimensions. It's very accurate. Most of them are thermoplastic. So they've got all sorts of initials, I guess, if you like. So these are known as TPOs in the industry, or PVCs, or TPOs, TPE, what did I say? FPOs.
Yeah.
There's even one out there called a KEE, which is a kind of PVC, and they're all thermoplastic membranes essentially, right? So this is what one looks like. It's made in a roll in a factory. It's then taken to the roof and applied to the roof. Unlike other types of membranes that are possibly liquid applied, the product's taken up onto the roof, and then basically the membrane's built on the roof. Single-ply membrane is then rolled and installed on the roof. So that's basically what a single-ply membrane is. So just going to share the screen here briefly, and where do we use them? So here's a very typical example of a TPO flat roof. Now TPO has its particular advantages in a climate like this, where you're collecting potable water. Due to the smooth surface of it, it's quite good for the collection of rainwater. Doesn't hold the dirt, and there's a lot cleaner surface. One of the other advantages with single-ply membranes is they're typically manufactured in a wider sheet. So some of them are up to 3.6 meters wide, which means fewer laps if that's something that you're trying to hone in on. The other, I guess, distinct advantage with the single-ply membrane is that they're either mechanically fixed or adhered to the substrate, eliminating the need for any heat or, any flame. So quite good in a remedial situation if you're trying to torch up an upstand or things like that. So that's basically what a thermoplastic membrane is and where we see it being used. It's no silver bullet. It's horses for courses, and it's using the best product based on its design parameters.
Yeah.
So what are the issues with a thin membrane? So I mean, what we're seeing, I guess our definition of a thin membrane is anything less than 1.5 millimeters. We think anything thinner than this is far too thin. One of the questions we found while we were researching this topic is, why do we even have thin membranes in the first place? Now, most of the membranes that are used in the New Zealand market are manufactured in North America. In North America, they manufacture thin membranes, and they are specifically used as temporary roofing. So for example, if they're building a great big mall, they'll use a thin membrane as the initial roof. And as they fill that mall with tenants, different tenants have different requirements around HVAC equipment and roof penetrations. They'll then fill the mall with tenants, put all their holes in the roof, and then they'll go back and they'll relay that roof with a proper thick membrane. Now, if we just look at the cross section of a typical thermoplastic membrane, you can sort of see what we're talking about when it comes to thickness. So what we're looking at here is a couple of slides. First one on the left here is basically shows the makeup of the product. So we've basically got two pieces of plastic that is laminated with a reinforcement scrim in the middle. So even though we're saying a thick membrane is anything above 1.5 millimeters thick, we also need to consider the fact that the reinforcement scrim is actually sitting in the middle of that membrane. So you've only got roughly 50% of that thermoplastic membrane is your weathering layer, your wear layer. And I mean, I say typically 50% because some membranes are actually manufactured with a higher thickness above scrim. Yeah. So you get a slightly thicker weathering layer.
Because we tend to consider, once that top wear layer has come down and you've just got the scrim exposed, we consider the membrane to have failed, because that bottom half doesn't contain the same substance. It's majority recycled material. It's there to give it body and to be there to manipulate. So it doesn't have the same quality as the top half.
Yeah, and yeah, like Peter says, once that scrim's compromised, so is the waterproofing integrity of your roof.
Yeah.
So obviously the downsides of a thin membrane are the fact that obviously they're quite easy to puncture. So it's quite simple to actually puncture a very thin single-ply membrane. And that's not the sort of thing we want happening on a roof. We want our roof to last a long time. So if the membrane's thicker, it's physically going to be more difficult to puncture. It's something that we must consider. Now, as Peter mentioned before, that thickness above scrim is quite important to the weathering. So that's the other downside, I guess, of specifying or using a thin membrane, is the fact that your weathering layer is a lot thinner. I think we've got a picture here of some thinner membranes. So I know that this roof here was approximately 4 years old. What else have we seen in this picture here, Pete?
There's a lot of patches going on here. A lot of those are from penetrations during the construction because they're only small circular patches. Then you've got a couple of strips that go the way down, and those are heading over laps, I'm pretty sure. And in other cases, they're longer kind of damage to the membrane. If you had a thicker membrane, these penetrations are less likely to occur in the first place, meaning that you're going to have less of these patches, if any, during your construction.
Yeah, quite interesting to note too that this, like I said, this roof's probably only 4 or 5 years old from our roofing report. So again, something to consider. Excuse me. All right, how are we going for time? Okay. What we've seen in this image here is again a thin thermoplastic membrane. As Peter mentioned again earlier, the thickness above scrim. What we're seeing here is that as that weathering layer or that top surface starts to weather and wear out, like all things do, that scrim is actually starting to grin or come to the top. Again, this picture here is taken from a roof that was less than 5 years old. Quite a concern. So these are the things that we're trying to eliminate from happening to our roofs by using a thicker membrane. Simply being thicker, it's just going to be more robust and last longer, with a lot more redundancy built in. So that's on the thickness of membranes. Like I said, just to recap, we classify anything thinner than 1.5 mil as too thin. It should be thicker than that. I'm just going to flick on now to the next topic we mentioned, is about heat and dark coloured membranes. Now, Pete, we did a bit of a science experiment with some TPO single-ply products in the market here. Do you want to show us up our little
so
grid here, mate?
We took 5 different single-ply membranes that are available in the New Zealand market. They're not products that you can only get overseas. They're all available here. They're not just TPOs. Some of them are different kinds of single-ply. We put them onto this board, left them out in the sun during, I think it was August?
October?
No, October.
Yeah.
And we measured the temperature of them each hour, so that we could see how they perform.
Nice. So we're just going to run our second poll now. So it's time to get interactive again. The poll thing's down here somewhere, so feel free to chuck your answers in. So the question for this poll is, what temperature do you think sample D got to? We did have a bit of a guess there. So we did this test, like Peter said, outside in October last year. Not in the middle of summer, just October. Nice. It was a sunny day.
Interesting to see what people say for this one.
Cool. Excellent. All right. Hey, thanks very much for participating in that poll. Right. So obviously there's a quick slide there of our sample board we put out there. We're going to flick around to the results now and show you some of the ranges that these temperatures membranes got to. So.
Yeah, so a lot of people guessed right on this one, but I'll go from left to right here. So membranes A and B were the lighter coloured single plies, and they come in at about 48 and 63 degrees were their top temperatures. Then membranes C, D, and E are the darker membranes. Sample C, I think, was a dark grey, and that comes at 94 degrees. Membrane D, which is the one was in the poll, reached 86 degrees.
Yep.
And then the darkest one, the black one that we've got available, membrane E, that reaches 99.5 degrees. Yeah,
that's pretty hot. I mean, if we're considering the fact that people are recommending that you set your hot water temperature to 55 degrees as a safety factor to minimize burning, many of those temperatures far exceed that. So, I mean, this membrane gets hot. What's the big deal around that? What happens? What's the downside of these membranes getting so hot, Pete?
Well, there's quite a few factors, Shane. The first is that these membranes have compounds in them, things like antioxidants, UV absorbers, heat and light stabilizers that are built into that top layer. They're not necessarily in the bottom one. So when you combine that level of heat with cooling and heating cycles, with rain, with UV, those chemicals end up getting worn down really quickly, which is part of why in the previous photos you see that wearing down and getting to the scrim quickly. There's a couple of other really important factors. If the membrane is reaching that heat, it's not just taking that on itself, it's bringing it down into the structure as well.
Right.
So if your membrane is 99 degrees, the substrate underneath it is definitely going to be getting to that temperature. So you're going to have expansion and contraction of your substrate, which puts stress on the membrane. It also causes heaps of thermal gain into the building. So the ceiling space underneath it is going to be way hotter than if you had membranes A or B.
Yeah, those roof spaces must get pretty hot, yeah.
Well, yeah, they also, I mean, because these are thermoplastic membranes, that high heat is actually going to soften them, which is not going to help when you've got, let's say, people walking on them, or something might potentially penetrate it. You've got a soft membrane, it's going to go through it a lot easier.
Yeah, right.
Yeah.
Cool. Now what's the other thing? I think we've got some slides here, Jade, of what the heat's actually doing to the adhesive.
Yeah, basic. Yeah. So these adhesives are meant to be applied, majority of them above 5 degrees. They don't mention maximum temperatures, but when you get up to those high ranges, they start to give up. So in this photo, what you're seeing is actually the adhesive failing to hold the membrane to the substrate. And so you've got bubbling all over the membrane. I mean, there's some other patches in this photo, but that's the main.
Bit of a bonus photo, isn't it? Showing the heat into the adhesive, and it's also showing some penetration patches that's been patched up.
Yeah.
Again, these photos from these roof reports, the roofs are less than 5 years old. So this is not an old roof at the end of its life. This is a roof in New Zealand. All these roofs are in New Zealand, and none of them are older than 5 years.
No, it's not ideal.
Quite noticeable what's happening here. So this picture here, we're sort of seeing, I guess this is a typical example of where the color of a thermoplastic membrane has been chosen for its aesthetics. It looks fantastic in the surrounding environment. It's a really nice place to go and visit. I'm sure some of you have been there. It's a nice little spot in New Zealand. But then if we zoom in, we can see some of the issues that have already been created on this roof here. What's happening with that heat doing to that membrane there, Peter?
Yep, so we've got bubbling, we've got discoloration of the actual membrane because you can see these white lines in it. You can see the substrates already showing through the membrane through that expansion and contraction. Yeah, those are the things that's easy to point out. The adhesive is already giving up on it, which is actually causing that bubbling.
Yeah. I guess one of the other things to note with this particular photo, you can probably have a guess roughly how old this roof is. The building itself still under construction. It's not even been lived in yet. So this issue's happened quite quickly in the scheme of things. All right. So where are we going for time? Well, I know it's very precious to you all. Here's probably the final horror shot here. What have we seen here, Pete?
Yep. So this is a bit of a perfect storm, this one. You've got a window to the left of this photo, and what's happening is you've got the sunlight and sunlight coming off the window converging in the one location. And so the membrane's reaching a temperature that's so high it's actually melting the plasticizer in it. So you can see all of this bubbling in the membrane is from it melting. And then if you look close to the window, you can actually see the reinforcement mesh kind of poking out there.
Kind of like holding a magnifying glass on your little plastic army men.
Well, that's basically exactly what's happening here. You know, it's being softened to a point where it's just bubbling away.
Yep. No, excellent. All right, we've got about a minute to go then we're going to jump into some Q&A. So get your questions ready. Just a quick wrap up. Again, we just wanted to highlight today around your unintended consequences of using, specifying thin and dark membranes. These are our learnings. This is what we've seen from roofing reports. Now this is the kicker. The last photo that we showed you in that slideshow was a membrane that Nuralite actually brought into the country about 10 years ago. So we've actually learned the hard way. This is our actual learning. We're giving you the good, the bad, and the ugly. We were lucky enough to be able to nip this issue in the bud relatively quickly. Like I say, that's something we brought in 10 years ago. Obviously, we stopped bringing in that membrane because we don't want to keep repeating the same issue. And we spent a lot of time, energy, and effort remediating the few projects that was used on. And we've learned from our lessons. and we won't repeat them. So we're trying to share those learnings with you. So
Yeah.
hopefully this has been relatively balanced, and it's not pointing sticks at anyone in particular. It's just to be conscious of your design thought around dark and thin membranes. Yeah, so that was our message today. That was the takeaway. I've got a few questions that have come in here. First one is around the sun tests. The question here basically saying that our other membrane, our 3PM membrane, is a black charcoal bitumen based membrane. Wouldn't that get hot? So basically what that looks like is it's a black membrane. This is our 3PM bitumen membrane. It has a granulated stone finish. One of the things is when this is laid as a system with the base sheet, we end up with a 7mm thickness in total. So it's very thick compared to the Single-Plies. The other thing that this does with the three-dimensional mineral chip on top is it provides micro shadowing on one side of the stone. So what we did do at the same time as we were doing the Single-Ply tests, we were testing the temperature of the 3PM finish, and that only got to around about 70 degrees, which is not too bad, considering that we're micro shadowing, and we've also got that real thick redundancy built into that system. Right, let's go through a couple more questions here. How do we nip our problem in the bud? Yeah, no, look, obviously we got highlighted to us that there was an issue with the project that we used this dark thin membrane on that we were bringing in, and then we just stopped importing it. And we told all our staff to stop promoting it, and we changed products, and we've now got products that have got a lot more history of use in New Zealand in our unique climate. So that's how we nipped in the bud. We just stopped doing what we were doing. We do know that out there, as you saw on the sample sheet there, that people in the industry are still marketing and promoting thin, dark membranes. Something we won't do. Our standard range is any colour you like, as long as it's dove grey. We also do white on indent, but anything darker than that, that's not us. We won't do it, and hopefully we've sort of shown you the reasons as to why we won't do that. All right, a couple more questions here. Can you put Nurajacks on this thermoplastic membrane? Yes, you can. Yep, that's a nice, easy answer there.
Problem. Pretty.
Which one's that one? You grab it.
Eddie's one.
Go for it.
Yeah, so Eddie asked the TPO beside the window, is that because it was a dark TPO, or what could be done to avoid this? Does this happen with normal grey? It was because it was beside a window, so not only do you have the sunlight, you've got it reflecting straight off the window. So you've got more than the normal amount that you would have there. You combine that with the fact that you've got a dark membrane, so it's actually going to absorb heat instead of reflecting it, which is what a lighter membrane does, and you're reaching really, really high temperatures in that spot. So there is a possibility, like if you if you got a room full of mirrors and put some sunlight on a TPO membrane, it could still happen.
I think it's called a solar oven, isn't it?
Yeah, basically, if you went out of your way to make a solar oven out of it, any membrane could still melt. But light grey membranes don't tend to have that effect on them, even if they're sitting next to windows.
Yeah, and the second part of that is what can we do to avoid this? Obviously, we can use a lighter coloured membrane, or we can use a different membrane type, or we can use a ballast roof if we had to.
Yeah.
I've got another question here. Is the performance of a single-ply membrane altered if it's laid over plywood versus over a warm roof situation? That is, I think it's a really good point. So the sample panel we did was on timber itself, directly to timber. My assumption would be that if you did the same test with the membrane directly on PIR board, or insulation board, that the temperatures would be even higher, because there's actually no solar gain or no thermal gain into the structure or whatever it is below.
Yeah.
That sort of 50 to 70 mil thick PIR board is going to completely isolate any temperature going down. So you probably get an even hotter temperature with a dark membrane in a warm roof scenario.
Yeah, so the membrane temperature will be higher, but you probably won't have the same substrate movement that if the membrane was straight on plywood, for instance, because the insulation itself is not going to be too bothered about that temperature.
Yeah, no, that's right. And again, to solve that, use a light coloured membrane.
Yeah,
would also do that. Right, let's have a look. Yeah, okay, there's a question here from Mark. Thanks, Mark. And he's talking about light reflectance values. So our standard product colour is a light dove grey. I said white is on indent only. Again, we're talking about being aware of the consequences of your choices. A white membrane is going to have a huge glare factor on any overlooking buildings. So that's something to consider. So that's why white is a special indent order only product. Something to think of there. Right. Okay. That's pretty much it. We've got a couple more here that are sort of repeats of one or the other. The minimum fall for the TPO is 2 degrees and 1.5 degrees on a deck, unlike the 3 PM system, which can go to a minimum fall of 180.
Yep, most single-ply membranes are in that category. They have to go to E2, which is 2 degrees or 1.5 degrees for a deck.
Yep. And we're just quickly going to finish up on the last question here. Can you overlay an existing TPO roof that is not looking so good? Yes, you can. There's a couple of options. I guess the first option, well, let's start with the best option. The best option would be to overlay that existing roof with a warm roof. So you would simply lay your PIR insulation board on top of the existing, and you'd lay your brand new membrane system on top of that. That's probably the best option. Alternatively, it is possible to overlay TPO with TPO. There's different methods in how we do that and what we can do. All right. Right, so there's quite a few more questions coming through. It's great to see so many people in the webinar today. So we're just going to run a quick poll while I wrap up today. If you could just rate our presentation. Should I stick to my day job, or do you want to see more of this? So going forward, we're going to be talking, our next learning series will be about tanking, below ground tanking, and then after that will be our learnings from warm roof construction. We've learned a lot about that. So just to recap today, it was talking about your design considerations and being mindful of the downsides of specifying a thin and dark membrane. I highly recommend you don't. These are our learnings that we are passing on. It's what we've seen in the industry, and we think it's best practice to share with you all, so we don't keep repeating these mistakes. I'm sure Boeing don't do the same thing. So. And just a quick final poll, if you'd like a follow-up today, one of our tech reps will be in touch as soon as you can if you'd like to follow up with us today. Big thanks to the attendees again today. Great to see so many people in the room. Quite humbling. So the Westpac chopper will be pretty happy. Going to take away over $2,000, so they'll be stoked. Thanks to the panelists. Thanks, producer Jade. Thanks, Peter. Thanks very much.
No problem.
Excellent. And we'll see you all on the next one. And that's a wrap. Thanks very much. Cheers.